So it turns out that this 96 is exactly equal to 160 minus 64. In other words, we've illustrated that it is indeed equal to the difference SST minus SSW. So the difference between SST and SSW can be derived by taking each within group mean and subtracting the overall mean. Okay, that's interesting. So what is the intuition here? It's not just that this is the difference between SST and SSW, there's something more. What this sum of square differences is doing is it's calculating how far the group means are from each other. So I've essentially reduced this data set to just two numbers, 12 and 4, and I'm seeing how far apart 12 and 4 are. This quantity, this discrepancy, is reflecting how variable the means in each group are. If the means in the two groups are very, very far apart, then all these differences will be large. If the means in the two groups are very similar to each other, then all these differences will be small. This quantity that happens to be equal to SST minus SSW also has a meaning in itself, which is it reflects the variability of the sample means, totally ignoring the fact that the data points vary around those sample means. So this quantity has a name, has a lot of names. You're lucky. So it's called the sum of squares between or SSB. It's also sometimes called sum of squares due to the model. Due to the model. So let's talk about these. So why sum of squares between? Well, because it's measuring the variability between the different sample means, right? So it wants to see how far apart the numbers 12 and 4 are. It's measuring the variability between the groups, not the variability of the data points within each group. That was SSW. But ignoring the fact that the data points vary within each group, it's measuring the variability between the sample means. So that's why it's called SSB. Sum of squares due to the model. Well, the idea is SST reflects the total amount of variability in the data set. SSW reflects the variability that's just due to noise, like due to the fact that not all the first years do the same number of extracurriculars. Not all the sophomores do the same number of extracurriculars, right? So that's just variability within each group. So the total amount of variability in the data set reflects the fact that not all the first years are the same as each other and not all the sophomores are the same as each other, but it also reflects the fact that first years and sophomores might be systematically different from each other. And that's what SSB represents. This quantity can also be called sum of squares due to the model because this reflects variability in the data that is not due to noise, but actually due to the systematic pattern, due to the fact that the mean in one group might be actually different than the mean in another group. So, okay, sum of squares due to the model, you could call it SSM. I've got another name for you. You can also call it the extra sum of squares. Why extra? Well, because it's the extra amount that SST is over SSW. The extra sum of squares. Okay. And so you can call this ESS. Now note, it's not the same thing as SSE. That was another name for SSW. So careful, okay? These different names are actually part of the learning. They're important to know because you will work with collaborators in the future who use any of these terms. Some are more popular than others, but not that much. You'll actually see all of them. And even as we move forward in different contexts, I'll use whichever one is conventional in that context. So you will see me use more than one of these as well. So now we've talked about three quantities, and let's summarize the relationship. Let me just write it down because this is very important. SST is equal to SSW plus SSB. This is called the sum of squares decomposition, and it is a famous and important result, and it's also the basis for most of the statistics that you have done in your life. Sum of squares decomposition. Okay, sum of squares decomposition. So SST, let's just sum up here, SST represents all the variation in the data set, in the whole data set. SSW represents the noise, or instead of noise, let me say the random variation within each group. And SSB represents the amount of variation in the data set that is due to the differences between the groups, or let's say between group means. So to say it again, the overall variability in the data set happens for two reasons. Why is it that not every person in the data set has the same number of extracurriculars? Well, one reason is that first years might have a different average than sophomores. Another reason is that the first years are not all the same as each other and the sophomores are not all the same as each other. So this result says that you can decompose the overall variability in the data set into variability that is due to the fact that the two groups, or however many groups, differ systematically, that's SSB, and variability that's due to the fact that within any one group, you of course don't expect all the values to be identical to each other. I'm not going to use this video to prove this particular derivation.